Yeah, so just to give context, I first started reading about TensorFlow, not right away. Yeah, these guys are the early adopters. They're helping contribute. A few people outside of Google, right? Like they don't work for Google. Yeah, which is kind of cool that they're accepting pull requests. Yeah, so I started looking, I think maybe January, February. I pulled down the white paper and it just sat on my hard drive for a while and knew that there were good patterns in there, good distributed patterns that I was reading about but hadn't yet seen. So but yeah, right when they came out with TensorFlow distributed, that's where things changed there. That's pretty much the big difference between TensorFlow and like Cafe and Theano and that kind of stuff is this whole distribution model, because they're all pretty much do the auto differentiation, which we'll talk, stochastic gradient descent, all those same things. Let me find the presentation that we okay. I think this is also my first talk where I'm not using PowerPoint, so we'll see how this goes. Try the new presentation view. Okay, got it. Yeah, Pete, can you hear me okay back there? All right. Yeah, we're recording this, so yeah, please don't stump us too much. Yeah, so first of all, I'm going to get the meetup updates out of the way. Yeah, I see a lot of familiar faces. This is great. You guys are, yeah, have been with me for a while. We'll talk about technology updates that actually some of them happened this week. Kafka 0.10 and Confluent 3.0 came out, a lot of cool stuff in there. Of course, Spark 2.0 is still baking, but pulled down early release and yeah, realized Zeppelin isn't compatible with Spark 2.0, so have to wait for the Hortonworks / NF Labs guys to get caught up there apparently. We'll talk about Spark model serving. So this is kind of the layer that my new company, FluxCapacitor, is focusing on. So everyone talks about training and that whole thing at Databricks, right? Like that's all we do is help companies train, and but then what do you do, right? Like where do you put the model? Yeah, to actually serve it up. So TensorFlow has something called TensorFlow Serving. I'm building the same thing but for Spark and for the JVM. So we'll talk about the patterns there. I'll show a demo of kind of early stuff we have. I say I'm in stealth, but I tell everyone what I'm working on, so it's not really that effective. Oh, and then, yeah, so somehow I got the first 4 bullet points here, but actually they're going to be the brunt of the talk. The second and thirds will be about TensorFlow. Yeah, so these guys have a lot of knowledge about sort of hidden gems within the TensorFlow, code-based things that have not yet been documented very well. People are kind of wondering. So yeah, these guys will help fill in some of those. Please ask questions too. Ask questions as we go. Yeah, the normal thing. Fabrizio is trying to get the distributed model, or yeah, the TensorFlow distributed demo working. This is going to be pretty demo heavy. We have a surprise demo at the end that I think is going to work. Right, Sam? Hopefully. Yeah. Small device, hint, hint. It's a form of a fruit. Let's see. Yeah, we're up to almost 3,500 members. This is pretty crazy. This has only been going on for about 10 months. Let's see. Yeah, we got the LA kid. Yeah, that's what I call him, Sam. Yeah, we got the Italian stallion. Yeah, I'm from Chicago, so of course I love Mike Ditka. Yeah, that was the Bears 49er game. I think the first game actually at the new stadium. I shaved my mustache, or my beard, and left the mustache for Ditka purposes. Pancake stack, I think you guys are all probably familiar. Come see the actual, yeah, oh yeah, so actually who went to the first pancake stack? Oh yeah, but you came in at like 2 p.m. and didn't even get a server. We give everyone their own Google Cloud instance. At the very end, we're gonna build a huge cluster. Each Google Cloud instance is chosen purposely because it has a lot of memory. I've kind of given up on doing workshops with people's laptops. It just doesn't work. You spend the first 3 hours, debugging or USB issues and, trying to get the USB to work and all this crap and Docker and everything. So it's just easier. It's not the, cheapest route, but each Google instance has 8 cores, 50 gigs of RAM and 100 gig SSD. So we're going to build, yeah, so these 2 clowns are going to be part of the fun on June 4th. So not only will we build a huge 800 core, 5 terabyte Spark cluster, but same with TensorFlow distributed. Yeah, and then the PANCAKE bot. Yes, I bought one of those recently. It was a Kickstarter thing. It takes about 45 minutes per pancake. But yeah, we have 8 hours together, so we can make about 8 of them. The first 8. This slide got busier and busier, but technology updates. So this is my part. Tech updates. Spark 2.0. We're going to talk about that. Kafka. CUDA 8, and then the CUDA neural network, the deep neural network library just came out too. There was a blog post, I think, even today or yesterday. So version 5 is out. Yes, I'm curious, like when will TensorFlow support it, guys? Yeah, has there been any word on the chat groups?
So they put out CUDA version 4 actually like
just recently, right?
Yeah, so right now they're on CUDA 7.5 and then CUDA in 4.
Right.
That, I mean, even that jump, I think, boosted their capacity pretty well. So I know that Google's working pretty hard, but the thing is they also want to make sure that when they do make the leap, that they got it fully utilized.
Yeah.
So they want to understand it fully.
Got it.
The main interest of QDNN5 is the recursive neural network. So there is the way NVIDIA implemented is to maintain state between forward and backward propagation. So that it kind of conflicts a bit with some internals of TensorFlow. One of the guys at Stanford is working with non-GPU but optimized LSTM. So there is something coming up pretty soon on RNN. And I know the state-of-the-art of neural networks are RNN. So
yeah. Yeah, the tough part with these neural networks is storing the state. Yeah, and I think we'll actually talk about. Hello. Okay. Yeah, so we'll talk a little bit about recurrent neural networks, and then LSTM, long short-term memory, where during the forward and then back propagation, there's state being stored. Right, so obviously this increases the memory footprint, and these GPUs only have 12 gig, 16 gig right now, just because of the physical architecture, the hardware architecture of these things. So it's commonly used in like NLP type things, where if you're sort of traversing along a sentence and storing the current gender that you found, and then you if it's plural or singular, and then once you come across a new gender, you would kick out the old. So just trying to figure out when you kick things out and when things stay in this forward and back propagation loop. Spark 2.0 core. Yeah, a lot of stuff going on here. The coolest thing is this whole stage code generation. So if you read this from bottom to top, which is how these physical plans read, right? Anytime you see this kind of tree, this took me like 3 years to figure out, you always start at the bottom and then move up. So what's happening is there's 3, so basically we're fusing together operators, like physically. So what's funny is I go back to one of my first or second Spark meetup talks, right, like this talk, and right, yes, I actually thought that this was happening back then, but it's not. So what's going on is like they're physically, right, like taking, right, like your source code, figuring out what you're trying to do. Here there's a range and then a filter and then an aggregation happening. So that's these 3. So those can physically be fused into one physical, right, like Java, right, like method basically. So yeah, so Spark 12.795 has the gory details here, but basically if you have 3 separate function calls, right, there's all these like virtual function, call chains and things like that, and then really pulling things into CPU registers, blowing them away. So here it's this whole stage thing. So each stage can now be collapsed into one physical method. This cannot be fused in because of the shuffle. Yeah, classic loop unrolling, SIMD code generation. So so at some point, right, like Mate, who's the creator of Spark, right, like one of the main guys behind Spark, he's at like MIT right now doing his PhD postdoc or whatever it's called. He has his little minions that we're working on LLVM. It turns out that if you can sort of give the JIT compiler, right, like enough info and like big enough batches, right, like vectorized batches, the JIT can actually compile faster code than like handwritten LLVM. So the whole LLVM thing was kind of hot maybe 6 months ago, and yeah, that's kind of fallen off the Spark plan. So of course, all this stuff speeds up CPU-bound workloads, not necessarily I/O-bound workloads. Yeah, I mentioned vectorization. That's basically piling as much data in as possible, not doing it per record kind of thing, right? It's Spark 12992. Yeah, has all the gory details there. Yeah, so vectorization is basically the optimization that's the fallback if they can't do the whole stage fusing. This is sort of like how PANCAKE works, right? Where you smash in all the column values together. So you seek once. This is in memory, right? So this is good stuff because the same way that PANCAKE and storing columnar on disk, right, lets you seek once and then, which is the slow operation, and then scan. It's the same way with memory. I mean, it's not it's not as noticeable, but you're still able to do prefetching, right? The CPU can pull in a bunch of data, can add up all those values, and not pull in this row, right? Push these out of the L1 cache, pull that one in, push, prefetch all this. Yeah, there's a lot of wasted prefetching happening there versus the columnar format. This is all specific to analytics workloads, right? Okay, finally, Spark 2.0. Yeah, all models and pipelines can now be saved and loaded. The one thing I realized quickly is that this code is all buried within the actual Spark models themselves. So you can't actually overload and say, save it as JSON or save as text file. It's just PANCAKE, it's just the format that Databricks has chosen, and yeah, that's all you get. So that's a little bit wonky, but yeah, I'll show some techniques to get around that. Spark 13.944 and 14.615. Yeah, man, that's crazy. My first contribution was Spark 1982, I think. Yeah, that's my sister's birthday. That's why I remember that. Yeah, so, okay, so these describe an actual drop-in replacement so right now, all distributed linear algebra, or yes, all linear algebra operations within Spark, all vector multiplies, or dot products, things like that, are all distributed, right? Which is why Spark is so popular, because it can break up these matrices into blocks and then do the math and then pull everything together. So that's not necessarily good from the serving, right? The model serving, the prediction layer, where you don't want to be spinning up a Spark job to just do one prediction and then, to just do one dot product and then return. So they actually use the same packaging. If you look at the actual library itself, it's mllib-local, or .jar. That's the actual jar file name, right? Yeah, so you can swap that in and then do all local linear algebra. Yes, I wouldn't pass anything too big, because then it's just going to take a long time, but it's the exact same packaging and everything. So yeah, this opens up the door to so this is FluxCapacitor's first product, which is Pipeline IO. It's the prediction layer. So actually taking, so picture you build a whole decision tree, save it out, what do you do with it now? So yeah, I can take in that PANCAKE and then productionize it. Basically, so each model becomes its own Docker image, and then I can scale that out crazy, right? Put it behind a load balancer, and then serve up predictions from that model. Okay. So I'll show an example of that later too. Kafka v10, Kafka streams are finally here. This is in the Spark streaming storm sort of realm, right? Just picture a little, so if you picture sort of like Lambdas in the Amazon world, but not shitty. So it's like little, yes, I shouldn't say that. I've never actually used them. But yeah, so I just read a blog post how they're shitty. So I'm just perpetuating rumors. So, but yeah, picture little nuggets of code where you can do joins, you can do things like that. Finally, Kafka 10 has this notion of an event the time it was created, right? Which just cracked me up, because why hasn't this been there since day one of Kafka? This is like messaging framework. It's a like an event-driven framework. This seems like this should have been there. Finally, there's like rack awareness. Uh-oh. Hello? 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 Oh. It just gets, it's getting too hot or something. Yeah, so rack awareness. Picture Netflix, right? They have a bazillion Amazon instances at like any given point in time. They need to make sure that the replicas for their topics and for their partitions within Kafka, right? So topic is like a queue, and then partitions, just a small section of that queue that's spread out, and there's replicas at the partition level. So, right, like before Kafka 10, these things could be anywhere, right? So there was no rack awareness, there was no data center awareness, no, right, like sense of a region, things like that, right, like an Amazon region. So if a whole DC goes down, like a whole AZ in right, like AWS terms goes down, you could potentially lose an entire, right, like all three replicas of your right, like Kafka, right, like topic. So yeah, we can thank Netflix for those contributions. Yeah, that's their stock symbol. Please, yeah, please buy their stock for no other reason than to pad my portfolio a little bit. Yeah, actually, I'm not a shareholder. Sold everything a while ago. Okay, Kerberos. Yeah, Kerberos, Sazzle stuff. Yeah, you can look into that on your own. Yeah, this is kind of cool too. You can actually pause a connector, which I didn't really think about, like why this is valuable. But like during maintenance, you can basically stop pulling. So the connector is actually, you know, pulling from Kafka. Basically halt it. Yeah, I'm going to upgrade myself and then really continue on. Max pull records too. This actually would come up quite a bit, especially in the Spark world, where you didn't really, right, like you couldn't limit how many records you were pulling. So it would just be arbitrarily, just right, like depending on whatever Kafka gave you at that moment. So now you can actually cap it out. Let's see, yeah, connectors. This is the first time too that you see Confluent actually have a right, like commercial paid product. It's called Control Center. Kind of reminds me of like DataStax with their, yeah, what's called DataStax Enterprise, where it has a nice GUI and all that kind of stuff, right? I think there's like a free 30-day trial, blah, blah, blah. Okay, so here's what we were talking about before, CUDA, CUDNN. Version 5 has better, or wait, this is the first time that it has? Really? Oh, yeah, I didn't realize that. Yes, I thought it. Ah, yeah, I thought this was just like an improved version of it. Okay.
How did you do RNN before? Yes, but it was only CPU. On GPU, you had to code it themselves. But then there is a nice post on the CUDA developer side where they show them how they partition the whole recursive network, and so it's 100 times, no, how many? 50 times faster than a naive implementation.
Yeah. So that's pretty cool. Optimized for the NVIDIA Pascal, right? Like, so the new GPU architecture, which has right the floating point 16, so the low precision. What you'll see too, and I think right, like Fabrizio or like someone will talk about this, but the actual right, like the ability to train at full precision, you know, 64-bit, 32-bit, right, like higher precision, but then go through and then for small devices and things like that, or for right, like faster scoring and classification, if you can actually get down to lower precision, so this is approximations upon right, like the original trained model. I think right, these models go down by like a third, right? So now you can fit something that was right, like 300 megs is right, like now down to 100 megs can fit on a device. They spend a lot of time right, like optimizing 3x3 convolution specifically. Yeah, does anyone know? Right, like do you know why they actually focused on? Because it's the most common? Okay. Boop. 1 second. Yeah, the HDMI port is the only port that actually works on my machine. Yeah, guys, this is Roger, by the way. Yeah, right. Like, has everyone seen him at pretty much every meetup ever? With his little setup there. So, yeah, he's my official camera person.
Yeah, I'm recording. Relax, make sure.
Yes, I see errors on your screen sometimes. Someone texts you and it like blows up, or getting like hits from OkCupid and Match.com. I see it. Yeah, don't think I don't notice. Okay, so if you guys have been like coming to this for a while, like this is sort of my reference app that I use to do a lot of demos, the flux capacitor pipeline. This was the original. It started off as a dating site, the creepy Spark After Dark. And then, come on, baby, hello. It switched to green. All right, so we're at green. Is there like a charger for these things?
The new one I changed.
Okay, got it.
Yeah, I put new fresh ones in this one.
Cool. Yeah, so, and then from like meetup to meetup, I realized I don't really do a good job of telling you guys what I put in since the last meetup. So this isn't actually from, I can't remember what I actually put in since, but this is the sort of hotter things that were on my mind recently. Yeah, has anyone used Jupyter Hub? This is the greatest thing in the world. This is like taking over. It's pretty cool. It gives you multi-tenant, right, like Jupyter notebooks, so you're not, clobbering each other. It's built into Linux security. Has all kinds of like security plugins. The one downside is it's Python 3 only. So I sort of forced myself to upgrade to Python 3 for some of the examples. It's pretty cool. If you're building a hosted service, yeah, this is what you want to start with. I attempted the Spark Redis connector. Couldn't get it to work, so I'm working with the Redis guys right now. Yes, it's like one of those classic times, and I didn't realize I was doing this, but I just went onto their GitHub and said, guys, this doesn't work. And they're like, okay, like, can we get some stack traces? And yeah, I mean, I was already like 3 problems past that, so I have to go back and reinstall the connector and figure out what the issues were. But yeah, added Theano. So as part of the pipeline IO stuff, the flux capacitor stuff, we'll be supporting like Theano models, Cafe models, right? Like basically the ability, you can push us any model and we'll deploy it. We'll like Dockerize it and scale it out for you. Keras, yes, I discovered Keras recently. People kept telling me about this, and I would Google it, thinking it was like carrot. Like I didn't understand the word that they were saying. Finally had someone spell it to me, realized, oh, okay, yeah, this is actually pretty cool. It's a higher level library that you write to. Yeah, so I should probably back up and say that like TensorFlow, Theano are very, very low level. You actually have to create the sessions. You have to build up these, you have to do a lot of hoops and things like that. It's super flexible, but for, like the 85% of the time, all you want to do is just do like image classification or like image training, things like that. So yeah, Keras, you can write to that API. It was Theano only. They just released, or not just released, but yeah, they've had TensorFlow out for a while now. So you can just plug in a different backend. I think there's another project called TF Learn. That's kind of the same thing, or like TensorFlow Learn. Okay, and then code-wise, I spent 1 year building this. Well, actually, no, that's this one. Actually, I flipped the order. This is code that actually takes the PANCAKE saved Spark ML, right? So if you build a decision tree with a pipeline and everything, right, like dump it out to PANCAKE. So this actually pulls that in from PANCAKE, goes through and builds an optimized POJO, just a plain old Java object, with just a big ass if statement, right? And it's if this decision point, that decision point, boom, boom, boom. So this is what actually gets deployed, gets Dockerized, gets pushed out and scaled out. This is using Janino, the same thing that is like powers the whole stage code gen, where it's taking in source code and then generating bytecode. Hot swappable, yeah, so I have code out there that within a single JVM is, yeah, so right now just watching on a file system. And yes, anytime a new model, a new version of the model comes up, it will swap it out and start serving that model. And, yeah, and similarly, you can actually go back to like older versions as well. So the start of that, yeah, made it into like the latest flux capacitor pipeline stuff. There's an eigen-based image recommendation. So again, back to the creepy dating site. Yeah, that's always in the back of my head. Where if you have, so right, like the use case here would be, yes, on Tinder, right? So you're like swiping, swiping, swiping. If you swipe left on Tinder, that's no, you don't like the person. If you swipe right, that's a yes. So at some point, your thumb gets tired and you can't swipe anymore. So right, like after about 150 swipes positive, that's enough to actually train this, right, like what's called eigenface, where you can take all those images, right, like simplify them down, scale them down, and then run PCA, so you find the principal components of each image. Yeah, so I have a full demo of this too that I can show. And then so from this point on, each new image that comes in, it can basically auto swipe for you. So it's going to decompose that like image and then compare it. If it's within a particular tolerance, then swipe. Yeah, so you can build a whole dashboard, or like wake up in the morning and check out. Yeah, these dating sites, man, I'm telling you, people think I'm weird, but there's a whole ton of stuff going on there. Right, like one other example too, I couldn't figure out this one, right, like girl's email got right, like bounced up, got like prioritized above other people's emails, which I only got like 2 emails that whole week, so it was just either, right, like email 2 or email 1. She got bumped up to number 1, and I looked at why. It was right, like purposely flagged, right, like not just, it just wasn't time-based. It was based on the words that were in there. Right, like she actually made reference to my profile, like things that were in my profile, like similar things, like Sonicare. I have 2 Sonicares because I'm, too lazy from the shower. Yeah, I like brush my teeth in the shower. Yes, I don't want to get out and get the floor wet to get my thing, and then, forget and just leave it in there. And so, yeah. Plus, Costco sells them in pairs, so yeah, I had to find a reason for that. Yeah, so she actually mentioned Sonicare. She mentioned Chicago, right, like some other things that were in my profile. So right, like that's pretty easy. That's just matching up, right, like engrams and things like that. Yeah, so also as part of this prediction service, right, like pipeline IO stuff, where we're serving up and then deploying models. Yeah, I'm using Hystrix, which is a circuit breaker by Netflix. This is a pretty famous architectural pattern where if you have dependent services that, yeah, so say that I'm an edge service that's talking to, right, like devices talk to me, and then I talk to, right, like tons of other services on, right, like behind the firewall. If some of those services go down or become latent, that circuit is going to trip, right, like open up, and then, yeah, so that does 2 things. That starts to return fallback, so you're forced to put in a fallback, which for the Netflix case would be, right, like top 10 movies from the week, just sort of non-personalized. But yeah, and then secondly, it helps, right, like that dependent service, it, right, like sheds the load so that service can then recover. Or someone can, right, like figure out that it's down and then bounce it or whatever. So the, right, like common use case there was when, at like Netflix, for example, right, so our group is on the edge, the streaming edge. So each device, whenever you press play, things like that, it would call into us. And then we depended on the actual recommendation service to, right, like serve up like the next 5 movies that they should be watching, whatever, or the, right, like next in the series. If that service went down, or say that, right, like our service scaled up super quickly because it was the Oscars or, right, like something happened, and we would forget to, right, like physically just forget to send them an email that we were scaling up. And then, yeah, we would just pound their service. So yeah, that's where that would come into play. Okay, quick note on the neural network landscape. So yeah, this is all the rage right now, but yeah, just to remind you guys, there's things like deep learning for J, which I think pretty much, or like everyone here has at least heard of, because it's like being developed here in San Francisco. Yeah, there's MXNet, Cafe, right? Like these have been around for a while. Yeah, there's Keras, Keras, in case you didn't put that together. Theano. I know nothing about this because it has the Microsoft logo, but yeah, like you know about this, right, Fabrizio? CNTK? Yeah, you mentioned it the other day. Okay. Yeah, he knows enough to stay away. Yeah, so that was his words, not mine. And Torch. So Torch is the one from Facebook. It's written in Lua or something. Yeah. So good luck with that. Okay, this is sort of the random part of my talk here, but this is a pretty interesting use case yeah, I was at Strata, I think earlier in the year, yeah, 2016, and so Stitch Fix, have you guys heard of this company, right? Does anyone use Stitch Fix? Come on, Roger. Yeah, this,
very good.
that right there.
I tell their meeting, they give very nice fashion shot. Every time give me 2.
It's a really cool office. They have clothes everywhere, and they have a really good meetup. Well, it's kind of a smaller meetup space, but they use, so separate from like neural networks, they use tons of ML. So the company, there's a human stylist that helps you pick out clothes. They send you 5 things, and I think they have a male version now too. And so the stylist that works for Stitch Fix, they're the ones that actually get the recommendations from the machine, right? From the machine. And then they choose the 5 that, because of their relationship with the person, it's right, like whatever they think. So this causes a slight problem in that the feedback loop, right? Like like typical recommendation collaborative filtering feedback loop has this like human in the middle that sort of screws things up. It's more personalized. It's a little bit more difficult to reason through. But yeah, they use ML for that. They use ML, so that would be collaborative filtering shown to the stylus. And then they use like NLP. If you send something back, you're forced to say why. And so they can then like start to associate terms with like negative things. And like when you start, you say whether or not you like things off the shoulder or like whatever like women do. Yeah, I don't really understand women's fashion, but now this is cool here. So this is using neural networks, taking popular items that they've been selling, right? So running them through so each neuron, each layer picks up different features, right? And then just sort of skew it, right? Like change things around, change the number of, right, these hidden layers, change the size of these layers, and then output, right, like different styles. So this one has sleeves in there. This one doesn't. Stripes going one way, right, like checker patterns. They send this back to the actual people that make the clothes. What's the term for that? The seamstress? What's the term for it? Yeah, I don't know. Yeah, tailor, I guess. This mass-produced, they send it back to Gap, let's say. They're a local company. And then they can start to decide and then figure out maybe we should be making styles like this. Super cool, right? All right, bonus slide. This is where I can't figure out where to put the slide, so I just call it a bonus slide. GPUs, I'm super excited. I'm going, not next week, but the week after, for a 4-day CUDA or like GPU training class, which like is just blowing my mind because these GPUs are pretty crazy. So typical CPU, you have all your different caches, things like that. You have a small set of ALUs. So here's your GPU. It's all ALUs basically. It's just doing math. So that's great if you have a lot of math to run through these things. So let's say now that you're branching. So let's take this piece of code, and that's the blue section here. So now these are all the cores, right? So these are all threads. So with GPUs, there's crazy amount of cores, right? They have like 4,096 cores. Super duper lightweight threads, right? The like switching costs are like super small for these thread context switches. The downside is that if you do any branching, these cores stay idle. So they can only run the exact same instruction at each instruction there. Yeah, all threads have to run the same. So if there's a branch, then these guys stay idle. So that's here. We go back to the other branch. Now it flips, and now these guys stay idle, and these guys are executing. And then back to like all of them executing. Right? Yeah, did anyone, I didn't know this. Is this new info to anyone? Did everyone know this? It sounds like a disaster for sure. Okay, TensorFlow Landscape. I'm just going to throw out a few names and then hand it over to the experts here. TensorFlow Core. So this is where you'll hear about sessions and like all the low-level fun details. Distributed TensorFlow. This was the new component that came out a few months after the original. So yeah, Fabrizio is going to talk about that. Sam's going to talk about TensorFlow Core, like best practices, hidden gems, things like that. So with distributed, you can actually mix CPUs with GPUs, and it'll basically figure out which ones are the, and there's this like super complex scheduling like piece of code where it's running little mini simulations, right? Like before it actually, like before TensorFlow figures out where it should be placing that like workload, and then figuring out like based on the overall, based on what's available at that moment, which CPUs are available, which GPUs are available. How long would it take for me to transfer the memory from the CPU to the GPU? Yes, I didn't mention that before, but CPUs and GPUs do not share memory. So to get memory from one to the other has to go across PCIe bus. There's this fairly new-ish protocol by the NVIDIA guys that's called NVLink, and that's an actual like electronic protocol down at the hardware level. Right now, it's just GPU to GPU. But yes, I believe it's like IBM that's working with, and it's specific to the Power series, the IBM Power series, where they're actually building that same connector between the Power CPU and like the NVIDIA GPUs. And I think that'll be available sometime next year, I think. TensorBoard, this is a way to sort of visualize, like what you do is during the training process, turn on logging. And then you have control over how often it's going to write things out, certain times that you want, certain conditions where you want these logs to get written, and then TensorBoard can go in and then visualize it. Like down to the level of like seeing how much error, like things like that. So this way you can change your hyperparameters and then rerun it and then compare. TensorFlow Playground is this sort of fun little toy, I call it. It's not really related to your models. It's just a way to sort of simulate like neural networks and see which neurons are picking up which features, and change the activation functions that are in each neuron, from like sigmoid activation to like the hyperbolic tangent, things like that. skFlow, this is really cool. So this is where that within like Google, they've needed this, right? They have code written to scikit-learn, or they want people who are familiar with scikit-learn to start using this TensorFlow backend. So this is called skFlow. Basically drop-in replacement. Not all of the algorithms are implemented from scikit-learn. But yeah, I mean, I tried it out. It's like literally take out your logistic regression, put in the TensorFlow logistic regression, and boom. It's like the same exact API. Keras we talked about. And then this new project showed up recently called Models. It's within the TensorFlow like GitHub project, and it's basically where things like the ImageNet model, like the latest checkpoints. So things that basically take a long time to train, they've just like built them and then pushed them out. So now you can just, from GitHub, pull them down and do your image classification. TensorFlow serving. I'll probably wait and do my demos towards the end of the whole talk. But yeah, basically you can do, here's your sources file system right now. That's kind of the reference. You would, when you build a new model, you would version it, basically +1 the old version. This runtime does the same thing, that like the model watching can see that there's a new model that's available. We'll swap it in. It will let the old model drain, right? So if there's like code that's already, if there's data that's already flowing through the old model, that'll drain out, that new one flips in. And like you can like roll back. So so this is what I'm basically modeling everything after on the JVM side. Picture. Yeah, so I just said keep an eye on my pipeline IO. I just bought that like domain today, and it costs, so I'm not gonna say the number, but it costs more than my first 3 Honda Civics combined. So, like they were cheap. I mean, they were like high school Honda Civics, but pretty expensive.